And what it means also is, as we are thinking about building new equipment, we can do real research with this equipment with a couple cyclotrons beams. And then, of course, the real thing is once you learn how to run this, you go with the effort driver and then do the research really very far out from stability. But the technologies can be completely shaken down with the cyclotron facility. Now, one of the issues we need to cope with, and we need input from the user community, is an issue of timing. I mentioned to you, I didn't call it out specifically, but construction of FRIP is sort of scheduled to be approximately 2013. Okay, so that's a long time. But there's some things which are obvious you could think of would be beneficial for the research program, for the user community. And that is if we want to go above the Coulomb barrier. So this area here is built, and we just have to fill it now with equipment. This is a cartoon. This will be user-driven equipment. And we are building, we are at the stage where we're tearing down this wall here to reconfigure things into the final configuration. And the stock beam area, the lasers and the pending trap will move into this room, and later on we can expand this room and convert the existing design area for the electronics department into experimental area. Eventually, if you want to go towards higher energies, you can build a LENAC, but then this would be up to 12. I mean, this is the existing high bay. You could build it, but then you have no use for it. Okay, you stop the beam right at the wall. So what you really have to do is think about, if you upgrade this LENAC, you build this building, you can actually carry the entire science program with the higher energies out much earlier with beams from the NSCL facility. So they're not as cutting edge and not as intense as with the EFRAG facility, but it gives everybody a chance to really get engaged in the research. It's somewhat similar to how RIC came into operation. Okay, they ran the AGS program, everybody got sharp, and everybody knew exactly what to do in order to do the science. And when RIC turned on, I mean, they had a fully trained user group, and I think the speed with which the science program for RIC came on, I think is setting sort of the standard how you want to ramp up science programs in the future. So we have the opportunity to do this, but this would require advancing construction of this high bay, advancing the upgrade of RIA 3, and we could only do this with federal funding. But first of all, you have to make sure the science case is there, the user needs are there, the user community is behind that, and then of course you need further dialogues with the funding agencies and see whether that could come into reality. But this would be one thing this meeting has to cope with. Is that an important issue? And we would want to hear that articulated in a clear fashion. And whatever is coming out of this user meeting will then be also conveyed to the so-called layman review, which we'll have in the beginning of September. So this is sort of the natural pace of things. Users articulate what they need, and then it's getting vetted with the various committees, with the federal agencies. Something less tangible, but certainly something which I'm personally pretty committed to, is finding other ways how to stimulate exchanges and intellectual interactions. And I want to mention that not everything can or should happen at Michigan State University. So we have to find ways how to do actually new ways of collaborations with national laboratories or with other universities. I like to call this the trans-institutional and cross-linked virtual institutes. One model is GINA, the Joint Institute for Nuclear Astrophysics. It started out basically as a letterhead, and by now is sort of a model for a physics frontier center funded by the National Science Foundation. There's many lakes in the country, actually with extensions across the Atlantic and across the oceans, where nuclear scientists talk about what experiments could be done at various facilities. It's not all focused on NSCL, but other laboratories are engaged, where observational astronomers are basically communicating what kind of observations they can do And then they talk to the nuclear scientists and say, well, and also to the modelers, what do you all need in order to make sense of all of this? So you have stellar modelers, observational astronomers, and nuclear physicists finding a regular platform to exchange the status of knowledge. And the way it's going, and Hendrik will probably talk much more about this, they're all influencing each other and driving the science forward. And I think there are a number of other opportunities. I mentioned the mesoscopic theory problem. Nuclear science actually had a significant impact on mesoscopic problems like, for example, atomic clusters. Okay, they discovered shells, and they basically transported the numerical methodologies from nuclear physics into a seemingly unrelated quantum physics problem. Actually, reversely, the chemists have developed a number of many-body quantum approaches. The coupled cluster approach, okay, which has found its way back into nuclear physics. So what we find is that if we find the community and expand beyond the reaches of the regular nuclear theory, we probably all benefit from it. So we've started a sort of a fledgling organization, a mesoscopic theory center, and the hope would be that it would grow into a network which again goes over many institutions of people trying to solve problems which are related, but not necessarily only the EFRIM problems. I think everybody will benefit from this. Another activity is EFRIM will have opportunities for true nuclear chemistry. I mean, we have nuclear chemists here, but they work like nuclear physicists. But the country clearly has also a need for nuclear chemists. And if we do go for isotope harvesting with EFRIM, that will be done by wet chemistry. So there is an opportunity for training the next generation of nuclear chemists. And actually, some of our faculty, Paul Mantica, has been organizing the nuclear chemistry summer school. So we are, again, engaging in the community in ways which are not directly focused on our own needs, but which address a broader common good. And I'm very supportive of that as a lab director. And then, of course, on the accelerator physics side, we also want to engage with a larger accelerator physics community. I mean, modern science has a lot of accelerators which work in different areas. Okay, the most important applications for accelerator physics perhaps these days and the broader impact are the light sources. Okay, and we have a strong community in accelerator physics, so it behooves everybody well that they're exchanging technologies and ideas as much as possible. And so we're doing this by engaging with the US Particle Accelerator School, which is really training the next generation of particle accelerator physicists. So these are just examples. We do want to establish an EFRIM visiting scientist program, which makes it really easy. If somebody says, you know what, I would like to spend the summer at Michigan State University to get engaged and really work and learn the ropes of the new technologies, we're going to make this happen. Okay, so we will provide some funding for this. And then, I mean, I talked this morning with Cyrus. Okay, I mean, how can we actually broaden out reach out to national laboratories and university and create joint appointments? So I think this is something where I would like to have a group of wise people sort of go from the talking stage into the action stage. Okay, and then obviously we will also have to talk with the agencies. But I think the flexibilities of sort of MSU as an open academic environment, we should take advantage and sort of develop a number of new approaches how we can strengthen the community in a much broader sense, which goes way beyond the direct local interests. And so I'm very interested and committed to make these things happen, and so is Brad. Okay, so I mean that's sort of where the director and the chief scientist will put a lot of effort into.